Hey all, very good morning. I hope I'm audible, right? Can someone confirm if I'm audible?
Good morning, sir.
Yes, yes. Good morning.
Good morning.
Yes. Good morning.
Good morning, everyone. Thanks for joining. So we are ready to start the session. All right. So just 1 minute. All right. So all set. Let me put it here. Okay. So welcome you all in the GuiNet technology, and today we are going to start this SD-WAN session, right? That is going to be very interesting for everyone because one of the emerging technology, in nowadays in the market, right? And if you guys are planning to upgrade yourself and you guys wanted to be, become a next generation network engineer, you have to learn this technology, right? So it's not a choice you can ignore, it's a mandatory you have to learn, right? So that's why like the in a market there is a trend, people are coming from the different background, like the network, they are coming from the security, they have done the CCNA, they have done the CCNP, they might know about the some firewalls like the Palo Alto, FortiGate and the checkpoints and some other firewalls and the proxy solution Zscaler as well. But when they want to grow in the next level engineer, and when we talk about next level engineer, that means you want to become beyond the L3 engineer, or even you want to become the consultant level role, architect level role, and you're having the multi technology kind of skills. But still, if you not having the skill of the software defined networking solution, that is SDN solution, you are incomplete for those profiles which are the very highly skilled profile available in the market, highly paid job available in the market. So that's the one story. So the market intent is, market need is, right, the person who is the very higher role like the architect consultant, they should have some kind of the very versatile kind of the skills where they have the very good knowledge about the SDN products, right? This is the one thing. But let's just suppose you are planning to upgrade yourself and currently you are working on the L1 or might be the L2. So your dream could be L3 engineer, right? Or even your L1, your dream could be the L2 engineer. And from L2 to L3, and then you can move for the L4 engineer like that. But currently in the market, trust me, if you just make yourself limited to the CCNP or CCNA, right, it is not enough for you. It is not enough for you. You can sustain for some period of time for the L1 role and the L2 role, but if you really want to grow for the L3 and L4 role or beyond of that, like the individual contributor role, so you have to upgrade yourself. You have to upgrade yourself, and this is the mandatory where software defined network SDN come in a picture. So SDN is a software defined networking concept where there is a three component. One is the SD-WAN, right? The one is the SD access, right? And third one is the ACI, applications centric infrastructure. So this is the Cisco solution. I'm talking about the Cisco solution. Different vendor having the different solution, but we are just focusing on the Cisco solution. So in SDN, you either go with the WAN solution, go with the LAN solution, that is SD-LAN. SD-access is the LAN. So this is again software defined, and just go with the data center solution as well, right? So this is a data center. ACI is application centric infrastructure. So either of these three, you have to upgrade yourself, and then you'll be become the next generation engineer, right? So one of the component we are going to start in today's session, that is SD-WAN, right? So we try to understand from the very basic, right? Because this is the first session where we are interacting with everyone, right? And this is going to be open session, so it's an English session. Probably after all like the closed batches is going to be start, then we'll see how many are the English speaking, how many the Hindi speaking. So accordingly we'll adjust the batch. But this is the first session, so we'll try to cover in the English itself, right? But still, if anyone having any doubt and like want to just get the clarification, feel free to raise your hand or unmute yourself, ask your query, just put in the chat, so probably I'll try to help you all, right? So this is the GuiNet technology. Here we are dealing with the multiple trainings, right? You can just go with the Cisco, Zscaler, Versa, Palo Alto, and the like the cloud technology and the firewall Azure. Anything if you want, you can reach out to the GuiNet, and someone will assist you about the training program, right? So the core agenda for today's session, why we need the SDN, right? And what is the benefit of the SD-WAN solution? So we'll discuss one by one everything, but we just have to understand a little bit the history of the SDN, right? So as I explained, when you talk about the SDN solution, right? So we having some kind of the chronologies, right? Like earlier, SDN is to come in a picture. So the first thing come in the market, that is the SDN, that's known as the software defined networking. So this is the first thing come in the market, right? And when it was come in the market, so this technology was emerged in the market, that is a software defined networking, in mid of the 20 00, right? So mid of the 2000, right? Means you can think about the May and June, this technology was introduced. Since almost 23-year back, right? So the concept was arrived in 2000 itself, and since then it's gradually start growing. But initially the concept of the SDN was a software defined void area network, or software defined networking emerged in the mid 2000. And SDN is a network architecture. The concept was a network architecture where your network can be more flexible, your network can be more scalable, your network can be operate via the programmable, program basis, some kind of the concept, and separating the main thing, that is this control plane and data plane. So there is two concept, control plane and data plane. So in current day, if you think about any router, any switch, any firewall, how the things is going to work for you. So let's suppose you having the one of the router. So in this router, we having two plane. You can just think about, or you can think about three planes. One is the data plane, right? And another is the control plane, right? And third one you can think about the management plane, right? So there are three planes. But when SDN was introduced, so the core objective was my network should be flexible, right? This is the core objective. So the first objective, my network should be the flexible. My network, my network should be like let me yeah. So my network should be flexible. My network should be scalable, right? So my network should be scalable. And the third thing, the network can be, you know, programmable, right? So this network can be handled by the programming as well. And most important, to separate the control plane in data plane. So this was the key objective when the SDN was introduced in early 2000. right? This was objective, but this objective was achieved in after 15 years working on this technology. Trust me, right? So the market recognition is happening after this concept. There was a lot of like in between, lot of things was happen, but the final market recognition was happened for this technology in around 2013 and 2015, right? And then gradually some organization start adopting these technologies, right? But the idea was my network should be flexible, my network should be scalable, my network should be programmable, and the separate the control plane and data plane. So like you guys can understand later stage what does means flexibility, what does means scalability, and how the programming is going to come in a picture. You don't have to do that, but there is some concept you are going to understand, and how data and control plane is the most important is going to be separated. So I wanted to just focus here. You can see this is the one router, and this router having the three planes, that is a data plane, that is a control plane, and that is a management plane. So why this three plane is going to be required? Why this three plane is going to required for the any router, any switch, any firewalls, right? So it is going to required because let's just suppose this router need to be remotely access. You want to remote access, right? Just I'm giving the example. You want to remote access. So this remote access is always going to happen via the management plane, because you should have the management IP of this router. You can allow those management IP through your network, and that can be accessible via the any of your jump server, any of the remote, desktop, any of the centralized location of the management tool. So that management plane come in a picture who responsible to just log into the device. You can fetch the report, you can get the configuration, whatever you want to do, interact with the device, that is possible with this management plane, right? What is my control plane? So control is the just, nervous system of the device. You can think about the brain of the device. So let us suppose I want to I want to I want to do some kind of the activity with my leg and my hand. So my leg and my hand cannot do itself some activity. They need some kind of the control information, right? So who is going to give the control information? Hey, you have to just do some, exercise by the head and by the hand of the by the leg. So that is going to come via your brain. So your brain is going to give the instruction how you can do the activities for your physical body. Similarly, control plane is the brain of the router who is having a responsibility to provide the basically some instruction how and when and what you have to do. So that is nothing, that's all your routing protocols. So that is your routing protocols. So that is the routing protocols that is going to available in this device. Means you have to configure like with the static routing, right? You can think about the dynamic routing, OSPF, BGP. You can think about the EIGRP, ISIS, whatever you can think, MPLS. That all is going to be, your routing protocol is going to be come in a picture, and they are responsible to do any kind of the decision making to just forward the traffic from one source to another destination, right? So those control information is going to come from the control pin, right? And actual traffic need to move from the router from one physical interface, this somewhat this is GE 0 by 0, to one of the switch which is connected here on the another physical interface. That could be the again GE 0 by 1. So data plane is something where actual traffic need to be processed via the physical interface device from one source to another destination through the physical port. So that is like actual traffic data need to be forwarded from my router to the other devices. That is my data plane device. So this was the and this is the right the how the router and the how the switch and how the firewall is doing the processing by the help of the three planes. But you can think these all data plane and this control plane inside of the router. Inside of the router means your router is doing the all decisions. Your router is doing the all decisions. There is no other third party vendor available who is doing the decision on behalf of you. So your router is doing the decision. So they are talking separate the control plane data plane, means the device should not having the complete data plane and control plane in the SDN solutions. This should be always separated. So how this is going to be separated? So the same scenario, let's say suppose if you are going to use the SD-WAN solution or SDN solutions, so you are having again a routers. So this router will be there, this router will be there, might be these are the routers. They are going to deploy on the sites, right? These are the router. So you can think about this is the R1, this is my the R2, this is my R3, this is my R4, and this is my R5. These all devices might be connected with the LAN with different switches. So these are connected with the switch, these are connected with the switch, these are connected with the switch, these are connected with the switch. So your data plane is always going to remain on this router. Means anything you want to communicate with your LAN or WAN, your data plane will remain there. So in between, we having the WAN circuit. Just think about this is your WAN circuits. So these are also going to connect there. They are also going to connect there. They are also going to connect there. They are also going to connect there, and this way, right? So these are the WAN circuits. So what is the different about the control plane? So earlier I told your control plane also available in the router. So how the earlier communication was going to happen? So let's say suppose this is my like the one of the PC, right? This PC want to talk to the this PC. This is another PC connected here. This PC. They having some source IP address. Just think about 10.10.10.10, and they want to communicate 20.20.20.20. This is my two source and destination I have, right? So if I want to communicate from this source to this destination, and I have the normal legacy router, then how my communication is going to be happen? How my communication is going to happen? So in this case, this my router is a normal router. This router is a normal router. Means they're not having any kind of the SDN flavor or SDN feature available inside of this router. So this is my normal router. So in this case, my traffic will going to come from this LAN. My traffic is going to come from this LAN, and it is going to ask about the destination IP address from the control plane device, means the control plane engine. So control plane engine is going to check the routing table, because the routing table is the intelligence, right, which having the all destination information. Likewise, you having the OSPF here, we having the EIGRP here, right? You running the BGP here, you are running the static routing here, and you might be running the ISIS, right? So these all routing protocol possibly going to a RAP if you're running the V2 version. So these all possible routing is available inside the router, any of them. So the device, once the packet is land from the data plane to this device, it is just going to consult with the brain which is inside of device. Hey, I want to go to this destination. Can you tell me the path? So this router control plane is going to tell, okay, you want to go, then you having this path. This path is available for you. So probably it is going to tell you can go via this to reach to this destination. So this is how your path is going to be decided. This router itself is going to tell the path. But just think about, I remove these all brains, means these brains from this router I remove and I put it somewhere here. So this is my all four brains or five brains. I put it in some different location. So this is my another box, right? And this box is the collection of brain. So this is the collection of brains. Means this router now cannot have the capability to do any kind of routing decisions. They cannot do any kind of the, you know, decision to send the traffic from the one source to another destination. They don't have, basically. They don't have brain, right? So how my communication is going to happen when I'm going to talk the SDN solution? How my communication is going to be happen? So in this case, what is going to be happen? My communication is going to happen in different way. And what is this different way? Probably my device is going to originate the traffic. Probably my device is going to originate the traffic from my PC and want to communicate to this PC. And when this is going to land to this router, because this router doesn't have the brain, so this is not capable to process the traffic to reach to other destination. Because we make these devices are brainless devices. So these devices are basically brainless device, right? So only having the control plane, all devices having the, sorry, only having a data plane, DP, the DP, all having a DP, but not CP. No control plane. Control plane, we put it all devices here. So these are the brainless devices. So in SDN solution, this was the idea to separate the control plane and data plane. And why? Because I want to do my all routing decisions somewhere in my central device, somewhere from the central device. So this device, which is the going to collect all the informations about the brain, that is the known as the controller. So this is the controller. So if this device want to talk to this device, they have to reach to controller first. Hey, can you just tell me the routing how I can reach to this destination? Then this controller is going to validate, and after validation, it is going to reply yes, you can reach to this device via this routing table. So it is going to reply you, and then you come to know how you can reach to this destination. So you cannot take self decision. You cannot take self decision by on brain because you don't have the brain. So you always have to reach to your controllers that is sitting in somewhere the centralized location. Might be I'm in India, so my India having the multiple sites. Might be the I'm in the Amritsar, I'm in the New Delhi, I'm in the Jaipur, I'm in the somewhere in the Mumbai, somewhere in the Chennai, somewhere in the Kolkata. So my branches are located in different locations, but those branches central brain I put it in somewhere in the Chennai, right? So they have to go in the Chennai always to get the information to just talk to one branch to another branch. So this is how controller come in a picture. But there is another story how this is not going to introduce the latency, how the network performance is going to be great by using this solution. We'll discuss step by step. But this is how my original concept is going to be come in a picture. We just have to understand this part first, right? So I hope you guys understand this, right? Let me know if anyone having any question till here because I'm speaking last 23 minutes. Anyone having any question about this solution? Please feel free to ask.
No, sir. No, sir.
Okay,
Clear.
good, good. Thank you. So let me back to the my original. Yeah, Jitendra, you having anything to ask?
Yeah. Hello?
Yeah. Yes, yes, please go ahead.
सर ये हैंग हो रहा है ना अपने आप ही सर ये
कोई बात नहीं, कोई बात नहीं. Yes, yes, please go ahead. Samsung, who is asking something? Okay, so let me move to the next step. Okay, so we understand about the idea about the. Yes, you asking something, Samsung? You can tell your name. I can put it here.
Yeah, my name is Ibrahim. I have a question regards the control plane. What's different between that the control planes and how does he make a routing decision once he has those protocols? How does he make it so that this is the best routing decisions to make to be able to route the traffic to the destination?
That's a really good question. So basically, Ibrahim is asking, based on the control plane, how it is going to make the routing decision to reach any destination. So I'm giving the very layman examples. So let's say suppose, just ignore this topology for time being. Let's suppose this is one of the router, right? Just think this is the one of the router, R1. This router is connected with one of the switch. This is my switch, and here one of the PC is connected, right? Switch having the IP address might be 192.168.10.10, right, /24. This is connected this way. I have another switch connected here, and this is another PC connected here. And this PC having a routing might be 172.16.10.10/24, like that, right? So this is my source and this is my destination. Okay. Might be I'm running here some routing protocol between the switch and the router here also. This could be my OSPF, right? This could be my EIGRP. right? And might be another network I have connected here, again switch 3, which is running some kind of the static routing, right? So and this one having also some kind of destination, could be you can think about the 10.10.10.10. So these are 3 destinations, right? And they are all /24 network. So they are going to reach via their own routing tables. So this routing table, when it is going to available this route in the routing table, so how my routing table is going to look like? So this router is going to create one of the routing table. So one is the routing table is going to create it for the 10.10.10.0/24 via the static. One routing table is going to create it 192.168.10.0/24 via the OSPF, right? One is going to create it 172.16.10.0/24 via the EIGRP, right? So this is 3 routing table available in my the brain. So once the packet is going to punt to this router, right? So this router, let's suppose you are coming with this source, right? And you want to go in this destination. So first of all, this is going to check this routing table have this destination route or not. If there is no route, the traffic is going to drop itself by the router. It is not going to do any further processing. This is simple philosophy. Means the packet is going to punt to my router interface via the data plane. So they want to go some destinations. Your packet is going to be created. Your packet is going to be created, and routing always going to happen based on the destination IP address. So let's suppose this is your packet. This packet having a two information. This packet having a two information. One is the source IP address, and one having the destination IP address. So my source IP address in that case 192.168.10.10. Destination I want to reach 172.16.10.10. So the first thing you have to always remember, routing always happen based on the destination IP address. Routing never happen based on the source IP address. Once you are just looking for the forward traffic. Once you look for the reverse traffic, routing always happen because your source is going to become a destination and destination is become the source because you are reversing the traffic. So it's always the routing is going to happen based on the destination IP address. So the router is going to check whether my routing table have this destination IP available or not. If the IP is available, so it could be this destination might be available right now. It is available with the one single source, that is the EIGRP, right? Right, that is available with the EIGRP, like the D routes. But it could be possible it is available with the OSPF as well. It could be possible it is available with the static as well. It is possible it is available with the BGP as well. So 3 possibility. Then which route is going to be selected? Which route is going to be selected? So in this case, my route is going to selected based on the lowest AD value. So my EIGRP AD value is 90, OSPF having the 110, static having the 1, eBGP having the 20. So which route is going to preferred? My route which is available by the static entry, that is going to get the preference for the same destination. But in this case, only one destination we have via the EIGRP. So it is going to check always this 90 route because no other alternative 172 route available in my routing table. This is the first criteria. But let's say suppose there is a scenario. There is a scenario. I am receiving the route. I am receiving the route in 2 copy in the same destination with the same routing protocol. Likewise, this way, I am receiving 172.16.0.0/16 route via the static, right? And I am receiving this route 16.10.0/24 via EIGRP. Which route is going to prefer now? Anyone can tell me? This is the EIGRP, this is the static. Which route is going to prefer now? Because
/24.
yes, AD of the static is 1, so technically this route should be preferred, but always in this case, longest prefix match is going to come in a picture. EIGRP AD is 90, but still this is going to preferred because it's having the longest prefix match. This route having the longest prefix match, and this is always going to come in a picture. So the router is always going to first check any prefix which having the same destination any longest prefix match criteria have or not. If there is no longest prefix match criteria and route is learning by the same destination, so then AD value come in a picture. And if AD is going to be, tiebreaker, then it's okay to process the route. So router always going to process by the help of the routing table, and after consulting the routing table, the destination is going to be checked, and then packet is going to be forwarded. Ibrahim, it is the same you wanted to understand, or anything else you want to just want to clarify
Yeah,
on?
that's okay. Thank you.
Yeah, welcome. All right, so this is about the routing decisions, right? So let me move. We understand about the control plane, we understand about the data plane, and like key concept how this SDN solution come in a picture. But we'll do the deep dive. I'm just taking the very high level because we are just starting. But how in the nutshell in the low level, how this all is going to be happen in the actual scenario, right? So let me just explain a little bit more about this, history of this SDN solution. So I told, let me just show you something. So you can see this technology was emerged in the SDN in the mid 2000, right? And later need of the WAN optimization was happen in the like the late of the December kind of the or November December of 2000. And then people are start talking about this SD-WAN solution around 2010 to 2012, right? Where the people in this period, like several companies, right, start developing solution. Not only Cisco, I'm just going to show you the multiple companies name, several companies. So if you think about a several company name, so we having the name like the, let me just write it here. So which we all vendors are available, right? So we having a Cisco SD-WAN, which is now known as the Catalyst SD-WAN. We having a Meraki SD-WAN, Cisco Meraki SD-WAN, right? We having the Velo Cloud SD-WAN, right? These are the vendors available in the market. We having the 14.8 SD-WAN, 14.8 SD-WAN. We having the Citrix SD-WAN. So a lot of vendor available in the market. We having the Versa SD-WAN, right? We having the Nokia SD-WAN, Nokia Nuage basically we called it, Nokia SD-WAN, right? You can just write in this way, Nokia Nuage SD-WAN. Also it is so, and also we having a Juniper SD-WAN. We having the river waded SD-WAN, right? So river wade SD-WAN, right? We having the Barracuda SD-WAN, right? We having the many more we have, right? We having a Kato SD-WAN as well. So a lot of vendors are available in the market, right? So you can think about it. So it's very difficult every engineer to learn all vendor SD-WAN solution because many companies are using a different SD-WAN solution in their network. So it is not possible all engineer can learn every SD-WAN solution. But why should I learn the Cisco SD-WAN solution? And what is the key advantage I am going to get if I learn the Cisco SD-WAN solution or any other SD-WAN solution? So main objective to learn the SD-WAN solution, just think about this way. You are learning the BGP. Sorry, this is the BGP is a routing protocol. You are running the MPLS. This is again the protocols. You are running them kind the OSPF, right? This is the routing protocols. Either you are working on the Cisco router, right? You might be working on the Cisco router. You might be going to work on the Juniper router, right? This protocol concept is going to remain same. The protocol concept is going to remain same. Either of the vendor, like you are running on the Nokia router, you are running in the Juniper router or the Barracuda router, the BGP is going to have the same concept. It's not like going to be, make any difference. The concept, logic, AS path prepared, your inbound, outbound filtering, your prefix list implementation, eBGP, IBGP, multi-hop concept, split horizon rule concept, right? Like how the packet flow is going to happen. This all is going to remain same. The way of configuration is going to be changed. Only the way of configuration is going to be differ. Similarly, in regard of the what vendor SDN solution you are learning, I don't care. but your all overall concept is going to be same. Your concept is going to be same, and after doing this concept, right? After doing this concept, you can basically implement and deploy everything in your network, right? So just give me 1 minute. So this is how it is going to be happen. So any solution if you're going to learn, this is going to be used, this is going to be utilized, and this is going to like give the significance kind of the knowledge how the SDN solution is going to work for your infrastructure. So the core concept is going to remain same, only the way of the implementation is going to be changed. So even you are learning the Cisco, Meraki, Velo Cloud, either of them, you can learn other SDN solution very quickly because the fundamentals concept are going to remain same. So this is how the vendors come in a picture. Now you can see in market recognition was happening around 2013 and 15 for this SDN, right? So what does means market recognitions? So market recognition means the SD-WAN solution start gaining attention from the market business, like the all companies who just wanted to optimize their WAN solutions, and that was a start happening around 2013 and 15. So companies start offering like the commercial product as a SDN as a commercial product, where many companies like with the Cisco, Meraki, Velo Cloud come in front and they start trying to sell their product to the different enterprise company like with the SCL, like with the Wipro, like with the uh, some banks like the good banks, some kind of FMCG companies. So a lot of companies are they just want to sell their product because they develop some solutions, and after that they wanted to sell this solution to the every company so that their network can be more robust, more optimized, right? So this is how the market recognition start happening. And but in 2016 and 18, that where the acceleration happens for the SDN solutions. Means the SD-WAN solution is get accelerated in the market during this period. So the companies start adopting. So market recognition happening in till 15, but 16, 18 was there where companies start deploying this solution in their infrastructure. And like after that in 2020, the maturation, like the maturity of this product and the diversification of this product is happen. And because the COVID also around landed in that time, and then companies start talking about the digital transformations. So that time, like the every company start deploying this solution, and till now they keep deploying the solution. So as of now in the market, every company almost having this SDN solution. So legacy WAN is almost getting out from the market, and new WAN is almost everywhere. So new WAN is almost everywhere. So you having a just limited knowledge for the like the CCNA and CCNP, right? CCNA and the CCNP, and you want to survive in the market, it's not possible. It's not possible. You have to migrate yourself on the SD-WAN because it's the market need, it's the mandatory. If you are not going to learn this technology, you're not going to, grow in a career. You're not going to get a very good job in the market, right? So this is how this solution come in a picture, right? So I hope you guys understand the critical, like this critical, like piece of this SDN solution, right? So let me move to the next section, right? We understand about the some uh, dates about this SDN solution. Now we just have to discuss about uh, like how this SDN solution is like make like our life very easy in terms of the after deploying this solution. So you can see here like we having a lot of benefits, but how this benefits is going to be tested. So we having this lab, right? So this labs you guys will get the access that can be accessed from the remotely. So this lab doesn't have any configuration. You can see we having a different component. You can see this is the vManage. We can see this is the vBond. We can see this is the vSmart. We having the vEdge routers. These are the branch location routers. These are not configured yet. We have to configure. We having some firewall. We having some cEdge. So we have to understand this lab, how this entire configuration is going to be happen, how the step by step my configuration is going to be done from this device point of view, and then from a scratch, I'm telling you, from a scratch we'll configure the entire thing for this SDN solution, and whatever the functionality feature I'm talking about, the control plane, data plane, that is going to test it in the lab environment, and you will feel like the your look and feel will be the similar you are working in the actual network, because these devices having the actual images, they having the similar license, everything is available. So if I just wanted to run something, you can see here this device vBond is going to be started. You don't know what is a vBond for time being, but later you will understand what is the meaning of the vBond, what is the vSmart, and what is the vManage, and how they are going to be configured. So we'll see that. So these devices is a zero configuration. We'll do the step by step, like the step by step all configuration, and all lab guides are available with us. So if you go here, so we created the very good lab guides for the every steps, so you will understand how my like the vBond is going to be configured, how my vSmart is going to be configured. So step by step configuration is written here, but I'll show you from the very scratch all this step how it is going to be configured. And after that, you can refer the recordings which you'll get after the every class is going to be finished. Then after you'll get the recording of the video, that is a lifetime access, and then we'll do the step by step configuration, how my system IP is going to be configuration, what is the meaning of the system IP, my system voice configuration, how my VPN configuration is going to be happen, what is my VPN 0 configuration, VPN 1 configuration, VPN 512 configuration, and other VPN configuration. So that also we are going to understand, right? And then we'll also understand how I can configure some routing, how I can do the certification part, how I can do basically some kind of the like basic root CA integrations, and then certification can be happen. So these all the steps are here, and you'll get the entire things from our side to just complete these labs once we start our actual configuration. Right. So this is about the labs and the lab guide. So see, probably it is going to start. So see, it is going to start, and here it is asking the username and password. So let me show you something. So you guys see that this is something, there's no configuration. It's a completely blank router. So no configuration here. So we just have to do a step by step all configuration to make this live. So we'll do latest stage how it is going to happen. Not probably today and tomorrow, probably in the next class, because a lot of theory we have to understand before we can go to the lab part, because it's the most important. And if we talk about the syllabus of this SDN, so let me just show you the syllabus as well, so you guys can understand. So how the syllabus is going to be aligned, right? So let me show you something so you guys understand what content is going to cover. So our training is just aligned with the completely Cisco official syllabus. It's not like you're going to miss something, but definitely you're going to get something more. Why it's more? Because uh, actual implementation, I have the experience how it has been done. Some use case that is not you'll find in the learning syllabus, but I can explain some policies, probably it is not available in this syllabus, but I'll tell you. So those things we're going to understand. So here you can see about the syllabus part. So syllabus having total, if you want to crack this exam, so this SDN exam, like SDWAN exam, basically Cisco known as the ENSDWIE version 1.2 exam. So you have to book this exam. It is going to cost around 400 US dollar to just book this exam. And after booking this exam is going to happen for the 90 minutes. So that is for the multiple choice questions, not labs you have to do, but you have to just, scenario based question you are going to get, and then you have to score more than 80% or 80%, equivalent to 80%. Then only you can crack this exam. So what is going to happen in this exam? What is the curriculum? So there is total six modules available. So one is the architecture, another is the like the you can see here controller deployment. We have in the router deployment, policy, and the security and quality of service, and the management. So if I go one by one, what is the happening in the one of the architecture sections? So you can see here in this architecture section, we having this kind of understanding required. Describe the Cisco SD-WAN architecture. In this architecture, you have to understand their component. What is the orchestration plane? What is the vBond NAT management plane? vManage control plane. So you can see in the lab also these devices are available, and vEdge is also available. So you can correlate what is the TLOC, what is the my uh, vRoutes, what is my data plane, that is a vManage. So I told, right, we have in the control plane and data plane. So the routers who is located in the site location, they don't have capability to do the routing. The routing decision is always going to happen from their, you know, centralized location. So this could be my centralized location where my routing decision is going to be happen, right? So that's the controller come in a picture. And this controller is going to give the entire routing information. So this is the why they are talking about the control plane. See, control plane is a vSmart and OMP, but data plane is the actual vManage router, IPSEC and BFD. Multi-region fabric, we just have to understand what does mean. Then we have to understand different like the platform, the capability of the SD-WAN, that I'll explain in the very deep dive. We'll understand what is the meaning and how this SD-WAN can be integrated with the software as a services. Like you want to integrate any SaaS application like the O365, you want to access the Salesforce, you want to access with the Dropbox, and many more. We have the software as a services where we are going to get subscription. So how they are going to directly access by the DIA circuit, that is the direct internet access circuit, right? How that can be, integrate with any Azure cloud platform, the AWS cloud platform, that is the infrastructure as a services, right? You can see IaaS services, and how they can be integrated with the co-location like any your small data center, regional data center, and multi-cloud like interconnect, how it is going to be happen. So this all we are going to discuss. We have to understand this all concept because we don't have to deploy, but we just have to understand. But more about the architecture point of view, you should know the theoretical stuffs. If you don't know the theoretical stuff, then probably you will be struggle to do the actual deployment. So architecture is a more about the theoretical, right? So we'll do the lot of theoretical discussion initially to just familiar with this all component, right? Sandeep is asking, please guide sir SD-WAN or just security checkpoint load balancer. Okay, Sandeep,
I have a
I'll cover.
question.
Yeah. Go ahead, Ibrahim.
Yeah. Do we have any requirements or any prerequisite, rather, if I may ask, to before you write this certification? Any
May
prerequisite?
say you are talking about the SD-WAN's certification,
Yes.
right? Yeah.
Correct.
So there is a prerequisite is going to required. So you can write one of the exam, that is a CCNP ENCOR. So this exam you have to pass before writing this exam. This is the prerequisite. Okay.
Okay.
So CCNP ENCOR, right? This is exam you have to clear. Then you can book this exam. This is the prerequisite. You cannot directly book this exam. So you have to pass this exam. So you'll
Okay.
get
So
that.
you have to pass. You have to pass the CCNP ENCOR before writing the SD-WAN.
Yes, right.
Okay.
So this is also applicable if you want to go with the CCIE as well, CCIE Enterprise Infrastructure. So it is also required even want to do wireless. So this is also prerequisite. So CCNP core is like the very robust kind of the certification which having the all flavor knowledge. Like you'll get the knowledge about the SDN as well, SD-WAN also, SD access also, right? You'll get about the knowledge about the DC technology, right? You'll get knowledge about the normal routing switching, right? And you'll get knowledge about another automation tool. So lot of topic we have in the CCNP in core. So it is always recommended. Anyone planning to go in the CCIE, it's mandatory also in the SD1. Probably you can just go and complete your CCNP in core as well, right? But if you want to just learn, you having the good knowledge about it. So if you want to just learn, not certification, if you just want to upgrade yourself, so if you're having the basic routing understanding, so if I'm talking about the basic routing and understanding, that means what routing level should you know? So routing understanding. So routing understanding, you should know how the static route can be configured, right? How the OSPF can be configured, right? And how BGP can be. So if you're having the basic knowledge of this static OSPF and BGP, then you can basically go with this solution as well. You can understand easily because the most of the concept are the very new. Most of the concept. Only when the LAN is going to be integrated with your legacy infrastructure, then these routing protocol come in a picture. These routing protocols come in a picture once the LAN. But if you talk about the WAN, entire WAN underlay is going to just come where you have to configure some static routing or BGP with the integration of the like the ISP internet service provider. Rest, everything is new. You can see even the syllabus. We can see architecture point of view. We having the SAS, ISO location. We having the other concept you have to know. Then you have to move with the controller deployment. These are the actual you can configuration you have to do that. So how controller can be hosted, how the installation is going to happen, how the redundancy is going to be created, how the certification part is going to happen, control plane troubleshooting, how it is going to be happen. This all is going to be covered. This is the first step in our lab where we'll do this all control plane deployment, right? Then once the control plane deployment is going to happen, vManage, root, CA, vBond, everything is going to configure. Then we'll move to the data plane to the actual site locations, right? So this is about the control plane. Then the router deployment we have to understand how my router is going to be deployed. You can see what is my onboarding process via the zero trust provisioning and via the bootstrap, how the data center regional hub deployment is going to happen. See this is my data center. You can just consider as a regional hub as well. And these are the branch locations. So this deployment is going to happen and what is the prerequisite, how the connectivity, how the redundancy is going to provide it. That is also going to be covered, right? And then we have to configure the circuit termination, TLOC extension, dynamic tunnels, underlay overlay connectivity. We have to understand and do all the configuration, how my basic IPv4 reachability is going to happen from the one branch to another branch, one branch to controller, one branch to my data centers. And then in top of that underlay, how we can build the overlay connections. So that is also going to be covered, and we just understand. Then we'll configure the overlay management protocol. That's very new. It's not the EIGRP, OSPF, and BGP. This is the one of the new routing protocol you are going to learn here in entire SD-WAN. How my communication is going to be happen, how the OMP is going to be, cover, and how TLOC is going to be TLOC, like transport location locator, how it is going to be configured. Then we'll see how my vEdge is going to be configured in the CLI mode and the vManage mode, and how my BGP, OSPF, EIGRP, and VRRP is going to be configured. HSRP is not supported by this SD-WAN solution, only VRRP. So we'll understand how this VRRP is going to be configured as well, right? And then we have to understand about the multicast feature. We have to understand the group feature profile in the workflow. This is the router deployment. After that, the most important part is this policy. This is the brain of this SDN. So here we have to invest our more times. We have to understand about the control plane policy, data plane policy. To understand about the centralized policy, we have to understand about the localized policy, and we have to configure end-to-end policy. How my traffic steering is going to be happen, how my traffic diversification is going to happen, how my traffic is going to exchange based on my intent. This is the key thing. You can just think about this, the engineering of this particular SD-WAN. So this configure control policy, control data policy, control centralized policy, control localized policy, VPN segmentation, topologies, right? How the configure application aware routing policy, direct internet access policy. These all we are going to do that in very detail. And even not only this, we having the many more to configure. In localized policy, we'll configure how the BGP is going to be influenced, how the OSPF route is going to be influenced, and how the localized policy is going to push from this control plane devices to the data plane devices, how the centralized policy is going to be, and what is their impact is going to happen in the fabric. So that also will cover in this particular section. Then we having a section that is a QS, where we'll understand how my QS is going to be configured. We'll see QS configuration, and in addition of that, we'll understand and configure the service insertion, right? What is the feature of the service insertion, how the third party firewall is going to integrate it. That's why you can see here we just having some firewall feature also. So we'll do this service insertion, and we'll understand some advanced firewall, next generation firewall feature also, which is going to be supported by this SDN solution. So we'll understand how the application aware enterprise firewall, what this means, right? IPS intrusion prevention system, URL filtering, advanced malware protection, AMP, SSL and TLS proxy, what this means, what is the trust sec, that we all cover, right? And then we'll understand about the DNS security, secure web gateway, what does mean, and then this all configuration is going to happen for this QS label, we'll understand. So a lot of thing we have to do and configure in this security, and also we'll understand TCP optimization, we'll understand about the data redundancy elimination, DRE, packet duplication, forward error corrections. And this syllabus is quite new, recently has been upgraded, so few topic they have been added. So now we just have to cover those topics, because earlier in syllabus in till last month this was not available here, and they have just updated. So we'll cover these all things as a concept. You don't have to do practical, because you have to know these all concept. That's why they are just talking about describe. Because if you're going to work as SDN engineer, sometime might be your security team is going to ask some questions, right? Just check the DNS, security and all, secure internet gateway firewall, the URL is allowed or not, right? So that you have to check. And we the last section we have, that is the management and operation. This is the more about your NOC perspective. You just have to understand how my authentication monitoring reporting from the vManage is going to be happen, right? How my configuration for the authentication monitoring and reporting is going to happen for the user and all, and what is the REST API monitoring and software image management, how to happen, how we can upgrade and downgrade the software image for the devices. So those also we have to understand from this section. So this is about the management plane. So these all entire syllabus we are going to cover throughout the session, and then we will be in position after completion of this course, you will get the confidence, like, yes, I know something and I can do some contribution for the next generation, like the network where I can support, I can grow my career. Okay, so this is about the syllabus. So let's
I
yes,
have another question.
yes, please.
Can you go back to that course content for that reason?
Sorry.
Yeah, I do not see. Yeah, so I don't know. Maybe you're going to cover it, yes or no. But I do not see how the troubleshooting part of it. I mean, for this, if it is not asked for the exams, but are you going to cover that in the class, in the training session?
Yes, troubleshooting is going to be covered 100%. So there is no syllabus you can see here, but troubleshooting is going to cover for sure, because we have to understand various scenario where we have to do the lot of troubleshooting. So when we do the LAN integration, when we just integrate the VPNs under the LAN, and we just have to propagate this LAN over the WAN, then we will find a lot of issues where route is not getting exchanged, where we'll see that my one VPN route is not exchanging to another VPN route, and we have to exchange that. We have to understand extranet policy. We have to understand my VRRP is not working. We have to understand my firewall service insertion route is not getting exchanged. So those kind of troubleshooting is by default is going to cover in every scenario. So we'll have to understand the redistribution troubleshooting. We have to understand how the route is going to be exchanged from the OMP to the BGP and OSPF and vice versa. So these all is going to come in picture while doing the configuration via the CLI and GUI in the SD-WAN configuration. That's a good question, Ibrahim. So no worry, this is going to be 100% covered. No need to worry about that. Okay. Troubleshooting is a part of the learning and our journey.
Okay, thank you.
Yeah, welcome. Any other question anyone have to ask till here? Feel free if you guys are comfortable in chat, just write as well. So I'll move in the different section little bit here. Yeah, Firoz, you want to ask something?
Yeah, sir. Good morning. How are you, sir?
Good, good. I'm doing great. How are you, bro?
Fine, sir. Fine, sir. Sir,
Yeah.
last we have also discussed regarding the SDWAN.
Mm-hmm.
I asked you one question, sir. Actually, my environment is like Velo Cloud.
Uh-huh.
So we have to work on Velo Cloud devices, and
Uh-huh.
many times I have stuck in this environment. So
Uh-huh.
I have some queries and I have cleared some concept on that. So it would be possible, sir, some Velo Cloud concept or some Velo Cloud topics, or maybe, sir, lab I shared with me. Lab is not available, but you can clear me some concept
Look,
on
so you,
Velo
you
Cloud.
ask your doubt. I'll try to clear right away if I can clear. There's no problem. Because I have the good understanding and the knowledge of the Velu Cloud. So you can ask right away. I'll try to help you. What is the query you have in the Velu Cloud where you are struggling?
Like some security parts and like policy part and like business policies and internals. So this type of the things, because I have joined before 3 to 4 months in my organization. So
Uh-huh.
I'm also not much more aware about the Velo Cloud. But right now I'm working with, so slowly I'm familiar all the things, but
Okay.
not get much more support from the other seniors, like, and understand what I want to say, sir.
Yeah, I
Actually,
understand. I
yeah.
understand. Now, see,
Yeah,
see,
that's why
simple
I'm
concept.
here
Yeah, Firoz,
requesting
I
to you.
understand. Yeah, I
Yes,
understand your concept. So,
yes,
likewise, in the Cisco SD-WAN policy, we covered in the previous batch, like how policy is going to be created and different use case we have discussed for the different policy, right? We discuss about
yes,
centralized policy, we discuss about the localized policy, we discuss lot of parameter in the centralized policy. So we have to understand every policy requirement having the different different use cases. Every policy having a different use cases. So
yes,
we have to understand, even you are the Velo cloud, we having the, like, let these routers are the Velo cloud, right? These routers are the Velo cloud based router. So these are the Velo cloud router based. So the normal concept is going to be same. Velo cloud also having the VCO, where the Velo cloud orchestrator, we having the controllers, right, where all the routing is going to be deployed and the routing is going to exchange, right?
yes,
So the concept is going to same, but when you start doing the configuration on the VCO or Velo cloud orchestration for all the policies, so that is the basis of your application. The policy is going to be defined based on the application, based on the ports number, based on your subnets, based on some kind of the other security parameters. So we have to understand like what exactly you want. Like you want to deploy some DIA circuit, you want to deploy some branch to branch communication, you want to make the hub and spoke for that policy you want to deploy, or any per tunnel policy you want to deploy.
yeah,
So that is going to be different. So unless or until in some day you can share your screen and ask me some kind of comment, then I can only share because or you having the specific question, like you can draw the scenario, then I'll definitely try to help you out, Firoz.
yeah. Actually, yeah, sir. Technology is same. That's why I prefer, and I had asked to you last time also, and I have today is also here. So just I'm
Uh,
discussing that. And because each and everything we can't clear a troubleshooter to ask to our seniors or like our team members all the things, because they have not a lot of time. But on that
huh.
way, I also a single option point of view use, so I can discuss with you and I clear my
No problem.
doubts
Just do
and
one
thoughts.
thing. Tomorrow also we'll have the same time session. You come with your
Okay.
scenario and draw some of your diagram. I'll give the access to share your screen. Okay. So
Yes,
other
yes,
people will also get the advantage for that. Okay. So I will
yes,
try my best to help you. Okay. You just come with some specific scenario so I can just help you, right?
Yeah, definitely.
Yeah.
Some tunnels, sir, some circuits like an ISP's lines and that type of the troubleshooting part, like sir. So we have to face some problems at there. So just I want to ask you that
So
will
in
be
Velo Cloud,
good if some troubleshooting.
in Velo Cloud,
Yeah.
once your circuit is going to be terminated, your both devices, the primary and secondary, is going to act as like single devices, right? In Velo Cloud,
Yeah, sir,
once
it's
you
a single day.
single
Yes.
device. So unless or until it's going to fail the
Yeah.
primary, you will not going to a secondary. Like in our case, these devices are going to two separate devices. So circuit termination is
Yeah.
going to happen in the most of the design on the some layer 2 or layer 3 switch, which is just in front of these devices, and they are logically connected to these devices, right? So you have to understand
Yes.
how the IP is configured while doing the onboarding, public IP or private IP address, and then you have to terminate your local circuit which is terminated on the switches as well. So this kind of the troubleshooting, you have to understand your network topology first, how my low level design look like, and accordingly you have to track your circuit like the connectivity ping and trace. So
Yes.
gradually, slowly you have to adopt, like with Cisco SD-WAN, you have to understand this Velo Cloud SD-WAN as well. So it will take little bit time, but you'll
Yeah.
understand.
Yeah, that's why, sir, I'm just asking on your behalf of that because in last only last time I think some network issue or what issue on that. So maybe I disconnected it there, sir. So I've tried to connect to you, but you was busy. I think so that's like
No problem, no problem.
not reached.
You can keep joining this session, okay? And we'll have a open discussion. No need to worry, okay? I'm very open, okay? Okay, so thank you,
Thank you,
Firish,
thank
for
you,
here.
sir.
So let me
सर
cover
सर
the last. Yes, Jit,
सर जैसे मतलब सर्टिफिकेशन करनी होती है सर प्लस टू से बात होती है
yeah?
सर जैसे सर्टिफिकेशन करनी होती है ना जैसे
Uh-huh.
तो प्लस टू से बात हो जाती है सर ये
नहीं समझा वो क्वेश्चन, कैसे, क्या पूछ रहे हो आप?
जैसे सर आपने जैसे प्लस टू कर ली होगी ना जैसे प्लस टू
हाँ.
तो उससे बाद सर सर्टिफिकेशन हो सकती है
Yes, you can do certification anytime. It's not like the mandatory, like the degree. You can do any certification anytime. Okay, plus two graduation, but it is not recommended. You just have to complete your diploma or graduation. But certification not having any prerequisite. Ki you just have the plus two level knowledge or like the graduation level of knowledge. Anyone can do the certification.
अच्छा सर
Okay, so let me just move the last section. Okay, so a little bit we have to understand uh, about the challenges and their flexibility of the SDN solutions. So we'll discuss again this benefits. I'll give the very real time live examples how these benefits are very useful for you. It's not the theoretical. I'll give the live examples like how and when you are doing these tasks in your legacy environment, and if you start doing the same task in your current environment, then how the benefits you are going to get that. Okay, but what are the challenges, right? If we talk about the challenges of the SDN, right? So software-defined wide area networking SDN solution address several challenges associated with the traditional WAN networking. And when you just going to deploy this SDN solution, those challenges are going to be mitigated. So the first challenges, if I am going to discuss, that is the optimizing network performance. So in earlier case, what is going to happen if you want to optimize your network performance, like the any application based, performance you want to optimize, your legacy WAN is not capable. Like see, so because they having a node capability to application aware routing, so they don't know how to optimize this application based performance. So to make this happen, application aware routing is available in this SDN solution, and this is allow like to understand the application based routing, and they can gather the information based on the application, and they can give the real time prediction what is happening with this application when user is accessing. So this is the how your performance of network is going to be monitored. It is going to be very productive. If anything you find that is not up to your organization's expectations, so you can just do the fine tune as well, right? So this is how it is going to be come in a picture. So the most important, that is the benefits or challenges which was having in the legacy WAN, that was the application aware routing was not there. They have the limited capability. But due to this, you can do the application aware routing based on the your various application. You go in the people Play Store, you having the Facebook application, right? You having the WhatsApp application, you having the Instagram application. So on these all application, you can do a lot of kind of the manipulations. It is also going to reduce your cost. How it is going to reduce your cost? I'll give the real time examples in later stage, maybe tomorrow. But it is going to reduce your cost because it having the lower dependency. I'm just giving the examples. It having the lower dependency on the MPLS circuits. You can use any of the circuits. It is going to use like the 4G internet, and your network is going to be secure. So MPLS circuits are quite costly, so you don't have dependency. Other factor also we have, which I'm going to tell tomorrow in the real time scenario basis. But yes, we can reduce the cost. Other parameter, we have to integrate our applications, our branch location to access the cloud-based applications. So this is going to enable you to just make the connectivity with the cloud-based applications, where basically you having the like the freedom. With the help of the direct internet circuits, you can reach out the cloud securely, and you can access all the application without lagging lane latency, right? It is going to introduce the lower complexity in compared to the legacy WAN. It having the very straightforward network, right? So your complexity is going to be low in terms of the monitoring, troubleshooting, configuration, and any other deployment. If you want to get that, is also possible. I'll again say the real-time example tomorrow class. Okay. Boost security, because these devices itself having the all security parameters. You want to do any kind of the advanced malware protection, you want to do any kind of the advanced threat preventions, you want to do the URL filtering, you want to do the file blocking, you want to do some kind of the DNS security, cloud-based security. That is all possible by the help of the SD-WAN solution. No need to buy any third-party firewall and all. This box itself having the capability to do these all kind of stuffs. So you can use this, you can deploy it, and you can just secure your network. But in the legacy WAN, this security is not there. You have to always depend on third-party firewalls, like the Palo Alto firewall. You have to use the FortiGate firewall. You have to use the Checkpoint firewall. Either of the firewall you just have to use. And after using these firewall, you can deploy your solutions, right? So this is the security. Performance is definitely going to improve when using the SD-WAN. How this performance is going to improve, I'll again give the right examples in tomorrow class, and then you will understand. Then the most important, you want to deploy any device with the help of the without any configurations, right? You don't have to depend with the any kind of the on-site engineer. Zero touch provisioning is one of the key things. We'll understand how this zero touch provisioning come in a picture, and how it is going to do some kind of the extra edge to our next generation networking. Just buy a box, connect to the WAN cable and connect to the power cable, and this box is going to be live. So this feature is just the zero touch provisioning. And what is zero trust fabric? So zero trust fabric by default, if you are part of the Cisco SD-WAN fabric and any kind of the device you want to onboard, right? By default, it have to prove their identity. I am the right person to join the fabric. If they are going to fail to prove their like the identity, they are not going to join this fabric. Okay. So this is how zero. So we'll do the lot of discussion on it in the next class. I'll show you some real life examples. Then I'll show you this how the complexity is associated with the legacy WAN, and how it can be mitigated with the next generation network, that is SD-WAN. And then we'll discuss how my control plane and data plane is associated with the one single router, which I just give the little bit flavor in the today class in the beginning of the section. But I'll explain how this router was there in earlier stage, and how this has been converted in the SD-WAN solution, where we having the control plane, data plane, and the switch fabric. So these all will understand the upcoming section. So I hope you guys are happy till now. Let me know if you're having any open question, if anyone have anything. Anything, guys?
Yeah.
Thank you.
Yeah, that
Yeah, Ibrahim.
box. Yeah, that box. Is that the physical? I mean, is that the SD-WAN, or what does that represent?
This one?
Yeah.
This one is not Cisco as this is normal router. This is normal router.
Okay.
Yeah,
The
we'll
question
understand
now
this.
is,
Yeah.
the question now is, the SD-WAN, does it have a physical hardware or just, I mean,
Okay. So SD-WAN having the both SD-WAN
yeah,
having the both the solution. Let me show you.
or buffer?
Yeah, this is the both solution. They having the physical boxes as well and the hardware means the virtual as well. So let me show you. I'll cover this. So this come with the different hardwares. You can see VH1000, VH2000, and VH5000. These are the hardware. But if you want to deploy in the cloud, it can be cloud as well, Azure, AWS, and the physical server. So likewise, right now we are doing all the labs in the cloud environment in the physical server. So this lab in the physical, so all are the VMs. But if you want to do in the actual devices, your organization might be purchase these boxes, which I'm showing here. So these are the hardware boxes, VH100, 100M, 100MW,
Okay,
1000,
so are you going to
2500.
touch, like, for instance, those boxes, physical boxes, let's assume they are placed in a data center or wherever. So when you want to start provisioning, are you going to discuss how it's being plugged, which one is blinking, where the power is, and stuff like that? The reason why I'm asking is, I think about 3-4 months ago, in a project I'm in, okay, so we have a lot of connection from from the data center technicians, asking them to connect one cable to another, but I don't have all those, those knowledge. That's why I'm asking. Are you going
Yeah,
to show
so
that?
yes, so definitely,
Are
definitely. So
told, once you understand, you can be
mhm,
given, okay, fine, I have the experience, you've learned this, you know this. How do you set it up from the beginning? Like, for instance,
yes,
like a FortiGate or firewall, right? You know how to deploy from the scratch. How do you this? Are you going to discuss on that? How to
yes,
deploy
definitely,
it from the
definitely. So
scratch?
that is going to happen from the scratch itself. So these all our deployment is going to happen the scratch. So let's say suppose we having any other router. So how by which port need to be connected to the WAN port, and what is a pre-configuration is available, and how we can fine tune the port configuration as per our requirement. So that we are going to understand, right? So let me this port. This is not showing. So let me find the figure. Let me just show you in this way. So let's suppose this is one of the router, right? So as you having any of the router, right? So those router having some ports configuration by default, right? Let me show you something. So let me show you.
I hope you understand what I mean. This
Yeah,
is
I
a lab,
understand.
right?
Yeah,
You
yes. This is the
can't.
lab. I'm also
Because,
I'm just going to correlate with the actual physical boxes as well. Just I'm going to tell you, okay?
okay,
So this is the lab, okay? So you can see there are some predefined ports available. This is the Ethernet G0 by 0, right? One port you can see. But if you're going to purchase the hardware, just think about this one, okay? So this port having 4x fixed GSAP. See, so 4 gigabit Ethernet port is going to be available on the box, right? So this is my 4 port is going to be available. Similarly to pluggable interface module, right? So we can insert the module as well on this particular box, right? They having a 2 SFP as well, right? 8 1 gig SFP also you can connect it, right? So basically we having the copper port, we having some additional modules, we having the fiber ports where we can use the 1 gig ports, we have to use the 2 gig means 20 gig ports, right? 10 gig ports basically, right? So these are available. So let's say suppose you purchase this box, right? And your organization is asking to take a WAN circuit, right? Just think about this is the
correct.
WAN circuit, right? ISP. And you
Yeah.
have taken the let's suppose here 2 Gbps speed link, right? 2 Gbps, right?
Mm-hmm.
The circuit. So which port I should select? If you are going to select this gig, that is a 1G maximum support. This is also 1G maximum support. So you just have to use this SAP one. We're having the 10G connection. You can see. So you have to terminate
Okay.
the circuit on the port. You have to physically recognize which port is the 10G. So you'll find the 10G port as available here. So you just have to terminate the circuit on the 10G ports. So in that port, it is going to be written. I'll show you in the diagram as well how it is going to look like. I will find the diagram, okay? Because I have already
Okay.
shown this. Yeah. So your connection is going to happen on this 10G circuit. So this 10G circuits is going to terminated, which port might be name as 10GE 0 by 0. This is the port, right? 10G 0 by 0. So your one end ISP cable is going to terminate on this port. And then you have to do the configuration on this circuit. Step by step configuration. You mean what I'm trying to say? And you asking the same thing?
Yeah, I
So
understand. No.
yeah, so
Okay.
this is how step by step configuration is going to happen. So in our scenario, it's not 10G port is available in this virtual lab. Okay, so we having the 1G port available. In all ports are 1G port. You can see here. So 1 gig port. So we'll understand the same scenario. My virtual router is connected here. My virtual router is connected here, and this router is connected with the ISP. So we have to configure. Might be I change the port as well. Right now it's connected G0 by 0, but I want to change some other port. So I can connect this other port as well, and I can do the configuration. So this all is going to be happen. This all is going to be happen.
Okay. Okay, that's good. Thanks.
Yeah, no need to worry about that. We'll discuss in very detailed and the real time examples. Sandeep, yes, due to network issue, I'm unable to continue the session because I'm traveling from the home work. Please guide me. So Sandeep was asking security firewall checkpoint load balancer, which one is the best? So Sandeep, may I know what is your current key skills and which domain you are working, so accordingly I can guide you. Can you just quickly post it, which domain you are working? You are working in the core routing switching, you are working in the security, yes, current job profile. Can you just put me here? He's doing chat because he is out of session. Okay, routing switching. So routing switching, if you are in the routing switching, so it's a high time to just move yourself from the routing switching to the SD-WAN. This is the first mandatory thing because routing normal switching is not no longer is going to be useful in the future unless you are going to attach with the SD-WAN. You can do routing switching work is still be there for some period of time, but you cannot get the more opportunity with the help of the routing switching. In addition of that, if we go with the one single firewall like the Palo Alto, FortiGate or Checkpoint, either of the firewall that is going to give the extra edge. Or you can just learn the load balancer. But I would suggest not go load balancer, just go with the firewall. Because firewall with the routing switching having the more opportunity. Load balancer you can do later stage. But first priority, you go routing switching SD-WAN plus the one of the firewall. This is my suggestion for you. Rest you can think accordingly, okay? All right. So I believe this session is good for everyone. So we'll connect tomorrow again the same time, and we'll have the another session because initially we are doing the short session, but later once we have the full-fledged classes, we'll have the 2.5 hour session, and 1 more hour you have to stay with me. Okay. So today we are just Firoz.
Sir, one more question. Actually, what is the plan? What is the timing of this schedule or session, sir? And how many time we will take to complete this session, all session? Matlab, it means course, sir. How many time we will take?
So class timing will be the in IST 10 to 12 30 p.m. 10 a.m. to 12:30 p.m. IST. That is the right now we are in the
What time
around
is
11 to, yes morning time only. So 2.5 hour per day the class is going to be started, and it is going to take around 2.5 months to complete. Within the 3 months it is going to complete. Okay.
Okay, sir. Okay, thank you.
what
Okay.
time is
Welcome.
that in EST, please?
Okay. So just give me current CST time. So right now you're 11:53 p.m. midnight, right?
No, CST. I'm on.
What is
Hold
current
on.
time? What is your current time right now?
Yeah, 12:53. Yeah, you're
Uh,
right.
11:53, right?
Yep.
Yeah.
Yeah.
So you just have to add 1 more hour where the class is going to finish. So right now 11:53, we started class 1.5 means around 9:30 your time. We started class 9:30 your time. local time. So 9:30 to you have to think about around 9:30, 11:30, 12:30, around 1 p.m. till
What? Okay,
around.
what day? Is it
Yeah.
Friday, Saturday, or what?
Yes,
How many
it's
times?
Saturday, Sunday. Only Saturday, Sunday. Only Saturday, Sunday. 2 days.
Saturday, Sunday.
Yes,
So
yes.
this one now is Saturday, right?
Yes, this is Saturday
This
in India time. This is Saturday in
which means my own Friday.
yes, on Friday. And tomorrow is Sunday for ours, so you'll be Saturday. So Friday and Saturday for your time.
Oh, okay.
Okay.
Okay. Thank you.
Thank you, everyone. See you again in the next class. Have a great evening or morning, right? Bye-bye. Take care.
All right.